let's try to control an LED with our Arduino. Now first, let's understand how an LED works. Right here, this is an LED. As you can see, it has two legs. All you need to know is that the longer leg is the positive side, the shorter leg is the negative side, and the current goes from the positive to the negative, so it goes this way. Current represented by letter I. So, as you can see in this diagram right here, we have a 5-volt battery. This means resistor. Basically, what we're gonna use to regulate this 5 volts and the current that goes through the circuit so that it is appropriate for our LED light, so that it doesn't burn it or it doesn't underpower, so that it doesn't light up or is too dim. So as we've said, first of all, the current goes from the positive to the negative side. So the current goes this way. Now, we have to know that for an LED, the usual voltage that we want it to get is around 1.2 to 3.6 volts and a current of 20 milliamps. And 1000 milliamp is 1 amp, so 20 milliamps is also equals to 0.02 amps. Now, in order to calculate the right value for our resistor so that it does the correct regulation, we need to use the Ohm's law. The Ohm's law. Now, the Ohm's law says that V, the voltage, is equal to I, the current, times R, the resistance. So, once again, this is voltage measured in V. This is the current measured in amps. And finally, this is the resistance measured in ohms. This is ohms. So for our resistor here, we want to find the right amount of ohms, basically, so that we get our LED gets these values. And how this is done is, first of all, let's take 3.6 volts as the target voltage. You can slightly change it if you want. And to do the calculation, first of all, we have a battery of 5 volts. So this is the voltage of the battery. And we take that voltage, because this is the main voltage that goes through the circuit, and we subtract the voltage that we want for the LED from it. So this is the voltage of the LED. And by that, we find the difference in the between the LED's voltage and the battery's voltage, which is basically, think of it as what we want to get rid of using the resistor. So this would be 5 volts minus 3.6 volts, and we get 1.4 volts. Now, this 1.4 volt is the amount that we want the resistor to take away in the form of, say, heat, right? And we plug this into the Ohm's law to figure out the Ohm's value for our resistor. So, with Ohm's law, V equals IR, so V, 1.4 volts. And what is I, the current? As we've said, 20 milliamps or 0.02 amps. So we go 0.02 A times ohms. And this is what we're trying to find. So if we divide 1.4 by 0.02, we get a value of 120. And what this means is that we want around the value of 120 ohms for our resistor to get 3.6 amps, 3.6 volts. And at 20 milliamps to pass through our LED. To begin, I have with me an Arduino Uno, the connection wire for the Arduino Uno, which you can also find in your house printer. It is I believe, USB-B to USB-A, a breadboard, a resistor. This is at 220 ohms, which is a relatively appropriate value for LEDs. You can go from anywhere around 100 to 1,000. They should all work, but like some higher values of resistance might mean dimmer LED, a blue LED, and 2 jumper wires, male to male. Now, first, let's look at the LED, right? As we've talked about, one side is longer, and that is the positive side. And if we grab our breadboard, we talked about how, except for the 2 sides, all of these are, say, these 5, A to E, are horizontally connected. So the circuit will go, if I plug something from A and plug something to E, and that's a circuit, it will work as a circuit because it's all connected by some sort of coil. Now, if I just quickly take the longer side on the right, plug the LED right here into the breadboard, plug it in. So the longer side on the right. Then I would take my resistor and use it on the positive side, which is the longer end, right? So it's on the right, so I would put one tail of the resistor on the same line or column, as you call it, as the long tail of the LED, and the other one at another row. Now, once we have this done, let's pick up our Arduino and look at it, right? So as you can see right here, there's a bunch of different places where we can put our pins into. And if you look specifically on the left-hand side, there is something that says 5 volts and something that's called ground. So we're gonna use these two to power our LED. So let's grab the red jumper wire, plug it into the 5 volts, and the other one into the ground. Any ground would work. And once that is done, we can simply plug the 5 volts, which is the positive side obviously, into the same row as the resistor's end. So the power will go from here because it's connected to the resistor, and then from a resistor to another row, which is then connected to the long end of the LED, and simply the other end, the ground, to the other end of the LED. Now, once this is done, you can plug in this side of the cable into the Arduino, and the other side into your laptop. If you're using Mac, maybe through a hub to change from USB-A, or simply use a power bank. And once it is powered, the Arduino, as you can see, the LED turns on. Alright, so now you might ask me, what if I want to actually control the LED, right? I don't just want to light it up because any circuit can do it, but like an Arduino doesn't have to be involved in this. So in that case, let's look at the right column of the Arduino. It's labeled in numbers, as you can see, 0 to 13. These are input-output pins, and they basically use low-high voltage to communicate a message, right? Say low is no and high is yes. So when it is turned on high, or when there is a high voltage, the Arduino knows that it's supposed to execute something. So we're going to use this function of the input-output pins to control our Arduinos. So what we're going to do, we're going to grab the red jumper wire and put it in one of the spots. Let's put it into 8. So from this, it's going to be put in the same place. We're going to put the red jumper wire to the other end where the resistor is connected, the same line, so that they're sharing. Then the ground is still the ground. The only change we've made is to plug the red wire into the input-output pin instead. And once this is done, let's go to Arduino IDE and see how we can code a small function or a small program for this. Alright, now I'm in Arduino IDE. So, as you can remember, we have plugged in our red jumper wire into one of the input-output pins of our Arduino Uno. And the specific number was 8. So, we're going to assign a new variable, an integer, that's called LED. And it is equal to the number that we have plugged the jumper wire into. So 8. After that, in the setup function, so the setup part is where all of the variables are going to be set up. You're going to tell the Arduino IDE what each slot is going to be. Is it going to be like an input pin or is it going to be an output pin, right? And in this case, our Arduino is outputting a voltage so that the LED can be light up. So we're going to assign the LED as an output. And how we do this is the command pin mode parenthesis, and then you do LED and all capitalize output semicolon. Now once you have set up the LED as an output, because number 8 is LED, you're setting up number 8 on the Arduino as an output to control the LED that's connected to it. We're going to go to the loop function. So the loop function is what is going to be executed like as a loop, right? It's going to be like constantly executed. And in order to turn on the LED, we're going to use the function digital write. So the function goes digital write with a capital W and the LED. So you're assigning LED, which is number 8, a high voltage so that it knows it is supposed to light up. And say I want to turn the LED off or make it not turn on after a certain second, right? We can use the function delay. And the number goes in milliseconds. So 100 just means 0.1 seconds. And you can copy the same code, but simply change high to low. And low voltage just means turn off the LED. And you can wait for another 0.1 seconds. So what we're going to do now, as you can see right here, we have our Arduino. We're going to upload our code. All right, whoops, I have to plug this in. So grab your USB cable for your Arduino, plug it in. In the tools, select the right USB port and click upload. I have selected the wrong port apparently. Yep. All right, now click upload. And if you don't remember, this on top should have been Arduino Uno. If you didn't do that, click select other boards and search up Uno and click on Arduino Uno to select the right board. And as you could have seen, it says successfully uploaded. And now let's go back to our main board. Because this has been successfully uploaded, let me just quickly put back the resistor. So as soon as I put back the resistor, you see that the LED starts to shine every supposedly 0.1 seconds. It turns on, and every 0.1 seconds it turns off. It waits for another 0.1 seconds. And from this, you can always adjust this value according to your own need. So let's go back to our code. let's say I wanted to not shine as frequently. So I'm going to make the delay to 1 second rather than 0.1 seconds. Again, just click upload. It's uploading. Now you can see it shines much less frequently. And let's say you want it to be like a different interval, right? Perhaps 500 and 100. You can do it. So just experiment around with different numbers. So now the rhythm changes. So what we have done by assigning the positive side or the positive side of the LED into an output pin from the Arduino and setting it up as an output and using the digital write function, we're able to control an LED with Arduino IDE.